Hello, good morning or good afternoon, everyone, and thank you for joining today's webinar, Intro to Multidimensional Kubernetes Monitoring. My name is Wing Sung, and I will be your moderator for today's webinar. Before we get started, I'd like to review a few housekeeping items. First, today's webinar will be recorded, and we'll send you a recording of the link within 24 hours, so you can share with your broader team that couldn't attend today. Secondly, there will be a live Q&A session at the end of the webinar, so please submit any questions you might have in the GoToWebinar control panel. And lastly, there will be a brief survey at the end of the webinar, so please take the time to give us your feedback. We always love to hear from you. And speaking today, we have Ali Jarrah from product marketing team here, and JF Jolie from our product team based in Barcelona. And thank you for jumping on, JF, at such a late hour for you. And without further ado, I'm going to pass it off to Ali to get us started.
Awesome. Thank you so much, Wing. And thanks, everyone, for joining today's webinar. We're super excited to share some of our most recent announcements around Kubernetes monitoring. I'm going to go ahead and get us started today talking about some of the challenges of scaling and observing a Kubernetes environment. And then I'm going to hand it over to JF, who's going to take us through a pretty amazing demo of our Cluster Explorer. But I actually wanted to kick this off giving a brief history lesson to give you all some context as to why we're even talking about Kubernetes today. And to do that, I'm going to take you back to a much simpler time when software architecture looked a little something like this. So if we think back to the times of VMs and servers, we actually had this pretty intuitive architecture, because at this point, there were really only two primary layers that we cared about. There was the application and the host running them. And while in practice, there's nothing wrong with this model, and many of you may very well have architectures that look just like this today, there's an emphasis and a need to move faster, which has begun this process of shifting away from VMs and towards a containerized environments. So containers as a concept have pretty profoundly changed the way that development and operations teams test and deploy modern software. And that's because, as compared to VMs, it's much easier to deploy and scale applications. Because containers are so lightweight and ephemeral, they can be spun up or spun down as resources increase or decrease, or as your applications need to scale. But there's also this conflicting challenge in that it is essentially containers create a whole new infrastructure ecosystem. So when you start to scale containers to run hundreds or even thousands of workloads, you're now creating this new set of operational challenges. And to deal with these challenges, we've come to this next iteration of containers and moved to orchestrated containerized environments. This has been largely popularized by Kubernetes, but the real magic of container orchestration is that it allows you to automate the deployment and managing and scaling of containerized applications. And this automation that I just mentioned is really the key, because it's what makes the ongoing process of orchestrating potentially thousands of containers manageable. There's also a bunch of other benefits of Kubernetes. And one of the main ones is that it's allowing companies to move faster. And in essence, what I mean by that is that now your development teams can quickly request the resources they need on the fly. So just to give you an example of what I mean by this, if development teams need more resources to handle additional load, they can request those super quickly, since now all of those resources are coming from an infrastructure that's shared across teams. There's also a major cost benefit of Kubernetes. And what I mean by that is because these containers are lightweight, they require less CPU and memory resources to run, which allows for way better resource utilization than, say, VMs. And then this last one is a major benefit and the portability that Kubernetes provides. So Kubernetes runs on all of the major cloud platforms as well as on-premise environments. And this is huge because now you can move workloads without having to redesign your applications or completely rethink your infrastructure. And so these benefits are a huge part of why Kubernetes has become such a hot topic and why we're here today. But just getting started and then running Kubernetes at scale isn't easy. And that's why we at New Relic fundamentally believe that wherever you are in adopting Kubernetes, monitoring is a critical aspect. And this monitoring needs to be adept to the new software architecture that Kubernetes has created, which means that you need visibility into all of these different layers listed here. So if you're running Kubernetes and you can't quickly answer questions like, what's the capacity of my cluster? Or is this impacting my customer experience? Or because of the ephemeral nature of Kubernetes, was my container running on AWS or Azure at the time of an outage? So in response to this, last year we announced our Kubernetes integration, which brings in system-level metrics so you can troubleshoot and alert on the most important parts of your cluster. And unlike some other solutions available for monitoring Kubernetes, we made it as easy as possible to get started. The entire process of deploying and configuring takes less than 5 minutes. The other thing that we wanted to emphasize here is that this integration provides application metrics and Kubernetes metrics. So you can view your cluster and get a good understanding of the application performance. But we knew we could take this a step further, and our customers were articulating different needs. They needed more than dashboards, and they were really telling us that they needed monitoring that mirrors the hyper-complex 3D nature that we're living in, and to be able to make sense of all of these complexities within their Kubernetes environment. Which has led us to today and the announcement of the Cluster Explorer. And this new Cluster Explorer is meant to provide a multi-dimensional representation of a Kubernetes cluster. So this is available today in public beta, and it is accessible to anyone with a New Relic Infrastructure Pro license who has configured the integration. So with that, I'm going to hand it over to JF, who's going to walk us through a demo of this amazing new Cluster Explorer.
Great, thanks, Ali. So I want to show you our Kubernetes monitoring integration, and I would like to start by the install. So showing you how easy it is to get up and running with it. It's just 2 commands, and those are copy and paste from our online documentation, so there is no complexity here. And the first thing I'm going to do is download our Kubernetes manifest for installing our New Relic monitoring. This is a manifest that will deploy a daemon set. A daemon set is an object in Kubernetes that ensures that one instance of our monitoring integration is running on every single node in your cluster, so that when you scale out your cluster, it will automatically deploy our integration on the new node with 0 interaction. So I only need to configure 2 variables in order to get this running. And I have here prepared a file with those 2 variables already configured just to show you. So we have the cluster name, which here is demo Kubernetes 2019, and my license key. That's all I need to configure in order to get running. So now I can execute this, which will deploy our daemon set in the cluster. So this is now deployed. It's starting the integration, and I've deployed it in my in a local configuration, but I could be doing that in a vanilla Kubernetes running on premise or in the cloud, whether it's on EC2 or EKS with Amazon, but also GKE, AKS, or with OpenShift. So let me show you quickly that this is running. So now if I look at the pods, I see that I have my New Relic infrastructure pod that is running since 29 seconds. So now let's switch to our user interface. As soon as I have configured this, I get this dashboard where I can see the information relative to my cluster. So I will see an overview of the resources that are being used, the objects that composes the cluster, as well as information, the classical information you would expect for any infrastructure, such as the CPU, the memory usage, but also the volume usage of your Kubernetes pods. We can also see some information that is specific to Kubernetes, such as the container restarts, which is something that's very important in the Kubernetes environment, because Kubernetes is managing the resources, and sometimes it might see that a container is unhealthy and restart it. So you will be able to see that. And you will also see the deployments that are incomplete. So a deployment is an object that defines the number of instances that you want to get running for your application. And if you have not enough resources or an issue with your application, you might end up with not having the number of instances you intend to have, and this will enable you to see that. And from there, I can directly go to the alerting and create an alert for my incomplete deployment, so that next time this happens, I will be informed. So let's name this incomplete deployment. And I will choose the alert available pods are less than the desired pod, which corresponds to a deployment that is incomplete. So it's not deploying as many instances as I want to have in my environment. And I can also filter this, for instance, to restrict it to only my deployments that are related to orders. So here in this example, I'm running a web shop. So I have all these microservices, such as the assembly of the order, the confirmation, the packaging. So all of this is running in a separate service, and I only want to get alerted for these services. So I'm going to create this alert, and that's all. Now it's created in my environment. So if I look for incomplete deployment, I see this created here just now. So that's the dashboard that we provided. Last year, we launched this, and it was GA for many months already. And we got great feedback on this, on how this helped our customers to manage their Kubernetes environment and scale with that. And there was a few additional scenarios that they wanted to cover. The first one was getting an overview that's really focused on the health. If you look at information such as the container CPU usage, as soon as you have many containers in your environment, it's sometimes difficult to make sense of it and know which ones are in trouble versus which ones are healthy. So that was the first thing. The second is they wanted to see the relationship between the entities. So how do you link the node where this is running to the pod, and then the container running inside the pod, and the application that this container is supporting. So getting all these relationships. And in order to do that, we created this new visualization, the Kubernetes Cluster Explorer, that shows you a view that's focused on the health of the cluster. So here I'm looking at a cluster in my environment. This cluster has 9 nodes. Each of these slices is representing a node and what's running on it. These rectangles are the node itself, with those 3 symbols that represent the CPU, the memory, and the storage. And you will get them to turn to yellow if they are in warning and red if they are in critical. And the slice itself will represent the pods that are running on this node. So if I look at the external circle, it will be representing the pods that are currently running and that are healthy, so they are not currently having any kind of issue. The second circle, the middle one, will represent the pods that are currently running, but they are alerting. They're having some kind of issues, and you may want to look into that to understand what's going on. And finally, the circle in the center represent the pods that are pending. So the pending pods are a very important concept in Kubernetes, that are the pods that are not running yet for some reason, either because they are unable to start, or maybe there's not enough resources. So you will want to take a look at why they are staying in the pending state. So next, you are able to see below the below this visualization, the table with all that information. The same information that you see in the diagram, you have it in this table here that you can focus and, for instance, sort by the CPU if you want to see which pods are consuming most CPU in your environment. Now, if I'm looking at a larger cluster, I may want to reduce the view to, for instance, a namespace. Here, as I'm running an example of a web shop application, I have this namespace that I dedicate to all my services that are interacting with the end user, the interactions. So here I will find the email notification, the order status, and here I have a canary version of my order status that is pending, so it's not deploying. So I can filter this view to get a restricted view that is purely showing me the information that is important for me and that is focusing on the health of the cluster. So with the many dimensions of the nodes, the pods, the status they are running on, but also seeing that from the namespace point of view. Now, if I want to see why those pods are pending, I'm able to go and dig into their current status. So here I can see that this order status canary, so a new version of my order status that I'm wishing to deploy, is currently pending. If I look at the status of the container, I see that it's in waiting. And it's actually, the reason is invalid image name. So there is a problem with the image name. And it's true that if I look at the image name, I see that it's canary image. So obviously there is this image is wrong. So either I made a mistake in my manifest, or maybe I have an issue with my CI and I should look at my pipeline or my Jenkins and see how it's configured. So I was able here to see very quickly what the issue was. And if I look at another example, the order confirmation here that is also having a critical violation, and if I see that the pod itself is running, but the container inside is in the waiting status, and the reason is crash loop back off. Meaning that in Kubernetes, this is a status that means Kubernetes is constantly trying to restart this container, which is crashing again, restarted, crashing again. And it's always, the back off means that it's always waiting a little bit more time to restart it. And now we are probably looking at an issue at the application level where my application, for some reason, is either experiencing a crash or using too much memory and having a memory leak and reaching to the point where Kubernetes is killing it because it's using too much memory. So here again, I was able to see what the status was quickly using the Cluster Explorer. Now, if I look at a pod that is in warning, here, the order status, I can see that it's running both of them. So I will take a look at the warning that I have here to see exactly what is going on with this pod and container. And I see that the warning is container memory usage is too high. So looking at this, actually, I can see that, yes, the usage is very close to the limit, which may be causing some issues with the application and also may generate a situation where if it crosses the limit, Kubernetes might decide to kill this pod and to kill the container inside of the pod. So that would be an issue. So now I can directly here see the status of the application that is running inside of the container. So here I see this order status, and I see that this is the application that's running on the container, and I can see the status of this application and directly verify whether this high memory consumption is impacting the application that is running inside it. So I see here the error rate is reasonable. I can directly see the transaction and the throughput for this application. And if I want to dig more into the status of this application, I can click on it and I will get a view, an overview of the status of this application. So here I clicked and I went to order status. So I'm now looking at the details of my application. I get the usual developer view of what is the status of my application. And I can choose one of the transactions, click on this, and get the details on a specific transaction, see how it's performing, what is its current status. So here I have clicked on it and it will show me the exact details of this specific transaction that I have chosen. So here I see this transaction trace details, which is my usual view for a transaction. But in addition, I will get information such as the cluster name from Kubernetes, the container name, the deployment name. So I will be able to see specifically what it's running on. So I will also see the node name, pod name. So I will be able to see what infrastructure is supporting, not only my application in general, but this specific transaction that I was running. So now if I take a look at our distributed tracing, I will find all the traces related to this application. And again, if I take a look at the details of a trace and dig into this to see the attribute of this trace, I will be able to see what Kubernetes platform, what piece or slice of the Kubernetes platform was supporting this specific trace. What was the cluster name, what was the container name, and the pod name that was supporting this application. So here I will find the pod name of the application. And now, if I wanted to filter on a specific platform variable, I could do that as well. So let's take typically the example where you have an issue with a node, and a node is starting to generate some problem, is going down or is having high CPU or memory usage, and you want to see how it's impacting your application. So you can now filter directly on this node and see only the traces that were running on a specific node inside of Kubernetes. So if you have several pods that are running on this node, it will take all the traces that were running on those pods. So really bringing the infrastructure and the application together. So that concludes the demo. I would like to summarize what we have seen quickly. So we've seen how easy it is to install, that in a matter of a few clicks, we were able to install our Kubernetes monitoring integration, and immediately out of the box we get a dashboard with the cluster level metrics that gives us specific metrics that are native from Kubernetes. And then we can jump to the Cluster Explorer, having this multi-dimensional view representing all the objects inside of Kubernetes, what is running inside of the nodes, how the application relates to the containers, what is the status of the native status of Kubernetes, but also the health of each of the pods. And then from there, we quickly draw the attention here, as we see, to the information and the problems that we have inside of this cluster. Then move to the application to correlate the infrastructure and its health with the health of the application that's running on top of it. So having this focus on health and an end-to-end view into your platform and your application. So that's what we have seen in a nutshell. Thank you.
Thank you, JF and Ali, for the really wonderful presentation and walk us through how Kubernetes monitoring works at New Relic. And I want to give everyone a few moments to some of your questions if you haven't already, and you may do so by doing a GoToWebinar control panel. And if you're interested to learn more about this topic, and this is the link on the screen, and you want to learn, there should be more additional resources on how New Relic can help you monitor your Kubernetes environment. And now we have quite a few questions coming in. So first one is, how does it scale?
Okay, so a couple of things. So first is the focus is really on the health. So I'm going to try to share maybe I could share my screen again just to show you the view. So coming back to the Cluster Explorer, so we are representing here a maximum of 24 nodes on this view. And if your cluster is larger than that, that's not an issue because we are focusing on the health. This is really the way we are going to make sense of larger clusters, because we see that you quickly get overwhelmed by the amount of information. So here we are going to sort the view by the problems inside of your cluster. So as you grow into larger cluster, you're going to have to be showing here in priority the nodes that have more issues. And here we see that these nodes have more issue, and as we go, there is in priority the critical ones. And here we finish by the nodes that have less issues. So that's the first thing. Second is, well, in order to not get overwhelmed by the environment and what you're seeing, you will want to narrow this view. So for instance, I mentioned taking a look at a specific deployment, but you could also take a look at just one of your deployments in your environment, and here it's running on only 3 nodes. So very quickly get a view that's much more focused on the issues that are currently present in your cluster. And then, in any case, if you are really looking for seeing all of the issues in your cluster, you will want to see the status in the table. And there you will get a list of all of the pods that are having issues. So you could put, if you really have a lot of issues in your environment for any reason, you will be able to see them all in that table. We got a few statistics from the main cloud providers on the size of the cluster, and in average we see that people are running between 3 and 20 nodes, and as well, now that you are seeing an increase in the managed Kubernetes, the things such as EKS or GKE, it's much easier to spin up a new cluster rather than using namespaces. So we see a lot of use cases where people will segment their usage into smaller clusters that are easier to manage, to upgrade, rather than having huge clusters with that are compartmented. Thanks for that question.
Excellent. We actually have quite a lot of questions. Next one is, can you show us how to monitor pod metrics, like how many CPU pod is using? And also, can we create alerts for pod CPU or memory?
So yes, we can see, I'm going to share my screen again. Not sure if it started. Yeah, I think so. I think you should see that again. So just here, if I click on one of the pod in this environment, so I will be able to see the CPU usage. So here I see 3 things. I see the CPU usage, the request. So the request in Kubernetes is what you've been asking for this pod, and is guaranteed. You will always know that even if you're in a shared environment, you get this minimum. And the limit is the maximum that it can use in any case. So even if the node is able to give you a lot more, you will never go above this limit. So you see these 3 values for the CPU, and you also see the same for the memory. So I can see here my memory usage as well as my limit, and here I see that my request is at 67 here. Now to your question on the alert. So yes, you can alert on a specific metric. So you could go to the alerts for the pod CPU, and here I can. So I have an alert here configured. Container CPU is too high, and here it's going to be based on the CPU limit, where I'm at 20% of that limit for at least 5 minutes. I will throw an alert in that case.
Awesome. And the next question is there an automatic outlier detection feature or a default set of alerts available?
So yes, we have a default set of alerts that gets deployed to an account when you activate your Kubernetes integration. So you will get a default set of predefined alerts that you can modify or that you can delete depending on your usage. And these will include the CPU and the memory in particular that we just discussed. And in addition, we have in Relic you can set up an alert based on outlier detection. So using either a baseline or outlier detection on a group of pods or of containers. So you could potentially say for a specific deployment, if there is any of my container that behaves differently from the others, I want to be alerted on that.
Awesome. And the next question is, do we have Kubernetes sample dashboard that could be used as a template for Insights dashboard?
We do have some template, some applications that we have a data applications that describe what could look like an advanced insights dashboard. Let me see if I could find that. I may be able to find that, but let me look for it in the background while we take the next question. I will try to find the link and open that and show it later.
Okay, moving on to the next question. Can I easily monitor auto scaling of containers?
So yes, I'm not sure about this question in the sense that you would auto scale probably the deployments, or you would auto scale the nodes to have more nodes in your environment. But in any case, when you set a monitoring, you can set it on a specific container or a specific pod if that's what you want to do. But in general, you will more want to set it on a concept that is at a higher level, such as a deployment or a namespace. And in that case, if there is more containers that are running inside of this deployment, you will automatically monitor them.
Got it. And then we have another one. Can we compare multiple Kubernetes clusters side to side?
So that's something we have in the roadmap actually. So that's something we want to give you a view for when you are running, let's say a large number of clusters, and you want to see an overview of each of those. So today you can do that building an Insight dashboard. So that's totally something you could do today. But we would like to give you a view that's focused on multiple clusters out of the box, and that's something we're working on. Yes. And just one second, just to come back to the previous question about building that more specific dashboards in Insights. I'm sharing my screen again, and I just wanted to show you this data app that is running in Insight, and is an example of an advanced usage for a Kubernetes environment running that is being monitored by Relic, and where you want to build a specific view on your environment. So here I have this application where I can see my cluster, but I can also see the deployments that are running inside of it, and I have a view that's focused on those deployments. So I see I actually see some specific variables such as the kills that are important in Kubernetes environments. And on the same view, I can see my application as well. So seeing my application that's running on top of Kubernetes and mixing information from the application together with the infrastructure in the same environment. So I just wanted to come back quickly to that question from Insights that we had previously.
Awesome, and we'll probably have time for 2 more questions. So can you alert on CPU or memory reservations on a cluster? For example, more than 66% of the cluster resources, as an example.
So yes, you could build that using we can. So we have we have an NIRQL, which is our language for querying the data inside of Relic. And based on this language, you could build some queries such as what are the what are the limits that I have set up in my cluster, or what are the requests that I have set up. So you could build up some advanced queries based on this.
And perfect. And I think this is the last question. What is the benefit of monitoring if I'm already using a managed Kubernetes service like GKE or AWS EKS?
Okay, well, so I guess the first thing is that more about half of the clusters we monitor today are running in a managed environment. So we do monitor a lot of environments that are managed, which shows that there is clearly a requirement for that. I think the question probably sparks from the fact that when you have a managed environment, you don't need to deal with the nodes, but yet in Kubernetes they are important. Your pods are running on nodes, and if those are congested, that is, if their memory gets overused, you will have issues with your pod running on top of it. And if you're you're still responsible for determining if you want to scale automatically or not, so you may run into this kind of resource utilization issues. So at the end of the day, even if you're in a managed environment, it's going to remove the tasks such as taking care of the upgrades, taking care of the initial installation. So it gets you up and going faster, but the health, it doesn't suddenly move the health problem away. Things might still fail, and you still need to monitor the underlying infrastructure.
Excellent. And if we didn't get to your question, we'll make sure to follow up with you individually. And that wraps up our webinar. And before you leave, please take a moment to complete the survey at the end. We always love to hear what you like, what you don't like, what you want to hear in the next webinar topics. And thank you once again to Ali and JF for sharing their insights and expertise. And thank you all of you for joining us today. We will send out the recording link of the webinar by tomorrow morning. So have a great rest of your day. And thank you once again for joining us today.
Thank you, everyone.